So welcome back to Right on the Edge. I've on my TikTok today, I've heard uh there's like a lot of news going on talking about Mount Rainier and how the activity level's rising and that it might be gearing up for an eruption. And I figured I would just look at a few videos of that today, see what's going on in that situation, and even see what's going on out in the Puget Sound because I heard that there is like a underwater volcano that's going to erupt, which is good for scientists, and that one should have like no effect on the shore whatsoever. So yeah, let's watch a few of these videos and see what is going on. Is it gonna blow any day now, or is this just normal activity?
This week, hundreds of small earthquakes have been detected at Mount Rainier, and this is the largest swarm of quakes in over a decade. But researchers say that this is normal behavior. Overnight, the U.S. Geological Survey also shared this graphic showing the earthquakes are really starting to die down to just a few small rumbles per hour. KOMO's meteorologist Stella Stun spoke with experts about the trends that they're seeing on the mountain.
Just a few rumbles per hour. I mean, I can see why people are fear posting, right? It's obviously for clickbait or something, but it's very interesting to see the activity rise in the entire Pacific Northwest region for the first time since, Mount St. Helens. I mean, obviously, it's always been active of earthquakes, but never so many at this time.
Standing tall at 14,410 feet, Mount Rainier is the highest peak in the Cascade Mountain range.
She's just really powerful, the way that she stands in the skyline.
An active stratovolcano.
Yeah, it's cool to drive downtown and just see that mountain in the background. It's gorgeous.
Covered in glaciers and ice, Mount Rainier is closely watched by the Pacific Northwest Seismic Network, which monitors earthquakes in our region.
We woke up to lots of notifications that there were a lot of little earthquakes at Mount Rainier. We do detect seismicity regularly at Mount Rainier, so it's not out of the complete ordinary. However, seeing this many earthquakes in a short amount of time is unusual, but it's not unheard of.
PSNS says 9 earthquakes a month is normal.
Yeah, that's what I had heard too. I heard that lots of small earthquakes all at once is business as usual in the Pacific Northwest. But it's interesting. It's very interesting. All right, let's find another video on it. Let's see. Let's see. Yeah, let's just see what this geologist has to say.
Yesterday, on July 9th, a swarm of earthquakes began.
Good job, YouTube. July 9th, it says 8th right here. Good job. Well, AI can't do everything right.
Striking underneath the summit of the Pacific Northwest's most potentially dangerous volcano, Mt Rainier. The swarm began at 1:29 a.m. in the morning, with quakes thereafter striking one after the other, sometimes multiple times a minute. This swarm is still ongoing more than 30 hours later, so far involving 221 earthquakes, marking this as the most intense seismic activity Mount Rainier has experienced since 2009, possibly even surpassing the swarm observed in that year. If you are wondering,
That's pretty cool. Yeah.
The reason why these cluster of events are called a swarm is that the earthquakes did not follow the expected rate for a simple aftershock sequence, which is represented here as the best fit 1/x equation. Here's an actual aftershock sequence for
Alright, yeah, just trying to read this real fast. Interesting.
comparison. So, should people panic? Absolutely not. As a geologist, as strange as this might sound, I wouldn't even truly consider the ongoing earthquake storm a form of actual volcanic unrest, at least not yet, because I see no evidence of a magmatic component to these events. Supporting my assertion, there's been no volcanic tremor, no increased gas emissions, no change in tilt-meter readings, and no new or existing ground deformation. Every important reading at the volcano is normal, so there's nothing to worry about. In other words, well, yes, Mt Rainier is technically an active volcano. At the present, it's still essentially sleeping with absolutely zero danger of an eruption in the immediate future.
Yeah, that's good to know. I mean, I kind of figured that it was fear-mongering, but it's good to have that verified. Not gonna lie, TikTok videos were making me think like, dang, that would be bad. That'd be pretty bad.
Hence the green or normal alert level. On my 0 to 10 opinion based on rest scale, Rainier's swarm earns it a 0. And yet, these quakes which struck could theoretically be considered volcano-tectonic earthquakes, but are not volcanic in the sense that the general public might think of the word. This might sound confusing, but volcano-tectonic earthquakes not only include those directly caused by magma movement, but also from tectonic forces that happen to slightly stress the volcano and the movement of fluids through pre-existing cracks. In the ongoing swarm's case, these events are almost certainly caused by fluid motion, just like Rainier's 2009 swarm. You see, meltwater from the volcano's melting glaciers, general regional precipitation, and groundwater combine and interact with the volcano's hydrothermal system. Due to the deep heat from magma, this can heat the aforementioned water, causing it to rise, and during this process, these fluids may interact with...
Oh, that's really cool. I never knew this. So it's really good to learn something. First thing in the morning, using my brain.
...with regional faults. This lubricates them, making it easier for them to slip and generate an earthquake. Wherever you go, below ground and sometimes on the surface, active fault lines are fairly common, and this includes at volcanoes, which often utilize larger faults as a path of least resistance for magma to ascend through. It's even been proven that sudden increased meltwater volumes, particularly during the hottest times of the year, such as July, can perform the same process. And
very fascinating. Alright, well that's Mount Rainier. Nothing going on there. Activity in the ocean. Because I forget what that thing is called.
Off the coast of Oregon and thousands of feet below the Pacific Ocean surface, an underwater volcano is showing signs it could erupt for the first time in 10 years.
Now, I've heard that scientists are really excited about this because every time the volcano erupts over there, the life tends to like rebloom and they're interested in like the growth on the ocean floor, which is super interesting, right? So I'd be happy to hear, like, I'd like to hear more about that.
At the University of Washington, scientists are studying what's known as an axial seamount. It's like a gateway for UW's cabled array, an undersea observatory that gives researchers a rare look into the Earth's geology. Inside the College of the Environment is one of the world's largest underwater observatories. Sensors stretch across the ocean floor, sending real-time data, including images and live video, giving scientists a clearer view of what's happening deep below the surface. Axial seamount isn't a typical...
Man, I like seeing like images like this because it's so cool.
Volcano. It sits above what's called a hot spot, where heat from inside the Earth pushes up toward the crust.
Awesome.
As the Earth's
Yeah, this is part of what I was talking about. Like, all this growth around here is caused by the mineral-rich water, the mineral-rich water in the area caused by the volcano, like, activity in the Earth's crust.
Surface slowly shifts, that hot spot doesn't move. Instead, a trail of volcanoes continue to form. At the end of 2024, researchers warned that the underwater volcano off the Pacific Northwest could erupt by late 2025, raising the question, could its release pose a threat on land? UW researchers say there's little need to worry because the volcano is deep underwater. The chances of it triggering a tsunami or earthquake are low. Unlike land volcanoes, this eruption isn't expected to cause widespread damage. It's too deep underwater and too far offshore for most people in the Pacific Northwest to even notice. The Axel Seamount has erupted 3 times in recorded history in 1998, 2011, and 2015.
Yeah, that's interesting. So it's a pretty active one as well. Yeah.
While there's no exact timeline for the next eruption, scientists hope to catch it in action using...
Hey, man, I hope so as well. It would be really cool to see the video of like lava just coming out of the ocean floor. It's cool how that's so hot that it, even with all that water there, just keeps on chugging.
Their underwater cameras. For Straight Arrow News, I'm Kaylee Carey. For more fact-based, unbiased reporting, visit san.com or download the Straight Arrow News mobile app.
Yeah, you heard him. If you like Straight Arrow News, go and download this app. You know what? I'm gonna subscribe to them. That's pretty cool. I love that it was just the news. That was very cool. Hold up a second. This volcano is full of sharks.
This episode is brought to you by GiveWell.org.
I have to know.
Go to GiveWell.org and enter Real Science at checkout to have your donation matched up to $100.
Hey, nice.
In the Pacific Ocean is a
Yeah, if you like this, you know, you can have your donation match up to $100. So consider that in the future, you know what I mean?
region that's been almost impossible to study. A region so dangerous, for many years, scientists didn't dare venture there. A place with nearly continuous volcanic eruptions.
Man, just look at all this sulfur and stuff just constantly coming out. At least I think if these are live clips, but that is so interesting.
Kavachi Volcano in the Solomon Islands is one of the most active underwater volcanoes in the world. It sits just 20 meters below the surface, and its base lies on the sea floor at a depth of...
Man, that is so cool. I love this type of stuff. This is so interesting.
1.2 kilometers. Beyond this, little was known about this volcano for the centuries it's been known to exist. That is until 2015, when a rare lull in volcanic activity allowed researchers to get close to its active crater and flanks for the first time. Using a combination of underwater cameras, recording devices, and scuba divers.
Man, you know they're waiting for this to happen, man. I would have been too. This is probably a once-in-a-lifetime event for some of these people.
The team collected a huge amount of information, even though it meant taking a few risks. Although the volcano wasn't actively erupting, gas still bubbled wildly from around the rim, which could cause caustic burns if the divers got too close. The team had to listen carefully to the water for the telltale rumble that comes along with eruptions, just in case Kavachi suddenly unleashed its fury once more. But what they found...
That's so brave, man. I mean, yeah, it took a lot of courage. I'm sure they went in, like, reasonably prepared, but, man, that was interesting, right?
Was worth the danger. Not only did they get bacterial and rock samples, but their baited cameras also captured some incredible sights. There were zooplankton and larvae as the scientists expected, but also something completely surprising. Schools of fish like bluefin trevally and snapper, silky sharks, and hammerhead sharks were all seen inside the crater. The water temperature above the crater was more than 13 degrees Celsius higher than the surrounding ocean, growing as warm as 29 degrees Celsius.
I just gotta check this real fast. What would that be, like, around 90 degrees? Ah, 85 degrees. That's still pretty dang, hot for ocean creatures.
What's more, the hydrothermal vents were still releasing concentrated amounts of carbon dioxide and sulfur dioxide, which makes the water much more acidic than normal. And yet this...
So over thousands of years, these creatures evolved to survive there. That's so cool. That's a lot of shrimp.
Vast array of life forms was still living in and around the mouth of the volcano. How are these creatures all surviving such an inhospitable environment? And what...
An octopus, man. Dude, they really found everything in there.
What can they tell us about the future of our oceans?
Who knows?
Kavachi is a fascinating example of submarine volcanoes, but it's only a tiny window into a vast underwater realm. Of Earth's 1,500 active volcanoes, the vast majority are found.
I mean, that makes sense, logically speaking. The world's like, what, 80% water, so the fact that most of them are underwater, that checks out. That passes the check.
In the ocean. Some are the result of plate tectonics, plates pulling apart or smashing into each other. Other volcanoes come from hot spots, which form not from tectonic plates, but from abnormally hot areas of magma that burst through. And erupting volcanoes are only a
Man, that's really cool. It's just boiling and steaming the surface of the water.
small part of the geothermal activity happening on the seafloor. There are also hydrothermal vents, which form when water seeps into the broken crust, gets superheated up to 400 degrees Celsius, and shoots back into the ocean filled with chemicals and minerals. Cold seeps occur in similarly volcanic places, but the water doesn't heat up. Instead, sulfide, methane, hydrogen, and hydrocarbon-rich fluids leak into the ocean, often for longer than hydrothermal vents. And then there are the megaplumes, which are like hydrothermal vents on steroids. These brief but enormous bursts of hot, mineral-rich water are still baffling to scientists because they're so hard to observe. But it's clear they have immense consequences.
I imagine this is important, like crazy important, because I bet you this is how the ocean gets its mineral content, which is required for, you know, lots of ocean life to survive. I wouldn't know the exact number, obviously, but you can think of coral, you can think of even shrimp and stuff need certain levels of like calcium and stuff to grow their shells. It's super, man, I love watching this stuff.
For surrounding ocean water chemistry, since a single megaplume can discharge more than 100 cubic kilometers of water in one go, the equivalent of 40 million Olympic-sized swimming pools. As for Kavachi, it's located on the Pacific tectonic plate, only 30 kilometers northeast of the boundary with the Australian plate. It's released huge quantities of steam, ash, and glowing bombs of lava on multiple occasions. It's even produced ephemeral islands up to a kilometer long over the course of its explosive activity.
That's cool. Making temporary islands. I imagine that they're just not, there's too much activity for them to stick around, you know?
Making it a very dangerous object of study. And all of this volcanic activity in Earth's oceans has had an enormous impact on the sea floor. Even long-extinct volcanoes have left traces on the underwater topography. The rugged hills and mountains created by volcanic activity are called seamounts, and they cover more than 28.8 million square kilometers.
That's wild. That's so cool. It's like a whole world that, well, obviously, but it's different to know something and then to see the data on it. You know what I mean? Like it's different to know something and then to see the data on it.
An area larger than any terrestrial habitat. Some of them are in the deepest, darkest parts of the ocean, while others come all the way up to warm, shallow seas. Scientists think around 45,000 seamounts exist all over the world, but we've explored fewer than 200 of them. In other words, we've seen less than 1% of what might be some of the most unique habitats on our planet. While researchers stumbled upon the first seamount back in the late 1800s, it wasn't until the 1970s that we first saw hydrothermal vents and the bizarre.
I'm shocked that it was that recent. I would have assumed it would have been a little bit older, but I guess this probably has something to do with technology at the time with like underwater breathing apparatus or suits or you know, things of that nature, because I know they started with those suits where they pump oxygen down from the surface.
Are creatures living around them. In 1970,
Underwater aliens. Great.
A team of 30 geochemists, geophysicists, and marine geologists came together to study the Galapagos Rift. No marine biologists were included because everyone assumed there would be no life to see. As they dropped their cameras down 2,500 meters below the surface, the researchers were surprised to see what looked like signs of heat. And then, to their shock, something even more unexpected came into view. What looked like alien life forms. Foot-long pale crabs. Red-headed tube worms the size of a full-grown human.
That's cool. I did not know those were worms. I thought it was like some type of anemone or something.
Clustered tightly around steaming pillars. They had discovered hydrothermal vents and the baffling ecosystem they support. From that point on, scientists employed a vast
I wonder if those crabs taste good. I'm just saying, I wonder.
array of technologies to continue exploring these underwater geysers. There's the Lost City hydrothermal field in the Atlantic Ocean, whose vent structures grow as tall as the Leaning
I would love to see that.
Tower of Pisa, and come from peridotite rock instead of basaltic rock, which makes up most of the ocean floor. This means the chemicals coming out of the vents around the Lost City have a much different composition than in other.
I want to look this up real fast. All right, yeah, she's just using clips of them, but let's. The Smithsonian. Oh, wow. I can see why it's called that. They just look like castles and trees. What's this? That's cool too. I mean, huh. They have like a little research station down there, I guess. Those are cool looking, but I can't believe they're that tall. I thought they were like zoomed in and stuff. Man, that's. I said it before, I say it again. It's very interesting. I should watch more and learn more about this.
Other locations, and yet they still support life. In fact, scientists have found around 800 vent animal species and countless microbial species, with many more likely to be discovered as we continue exploring the deep ocean. In addition,
I imagine a lot of the studies are held back by the fact that when it's active or too active, people can't go near there.
in addition to the tube worms and crabs scientists first saw in the 70s, we now know there are also giant mussels, shrimp, and perhaps the most important organisms of all, microbes, that survive alongside the vents.
Yeah.
These microbes make up the entire base of this strange food chain, and they do it in a place where there's no sunlight at all for photosynthesis. Instead, the microbes convert inorganic compounds like hydrogen gas, sulfur, methane, or iron into nutrients. This allows the microbes to thrive in what would otherwise seem
I mean, there's microbes that eat everything, so that's super cool.
like hellish environments, and support many other organisms as well. These microbes help explain the surprising amount of life around Kavachi. The researchers found bacteria related to Sulfurimonas, which use chemosynthesis on sulfur and carbon dioxide to produce energy. Filter feeders like krill and clams can survive entirely on these bacteria, and those populations in turn can support bigger fish and even sharks. It's all part of.
That's awesome. Yeah, that's gonna be it for me though. I'll have the links to these stories in the description below. And yeah, thanks for coming to my channel. I hope you guys like this sort of content. I know I do. If you find it interesting, just let me know below.